Altura agora para termos um painel, um debate que vai falar de aeronaves não tripuladas, é precisamente esse o tema, como integrá-los e promover melhores instrumentos em prol de uma maior segurança e eficiência. Participam neste painel Clélio Leite, Presidente da Associação Portuguesa de Aeronaves Não Tripuladas, que também modera este debate. Olá, viva, muito bom dia ainda. Quer dizer, já é boa tarde, já passa do meio-dia. Depois, Hakim Friedl, Presidente da EASA Joint European Drone Associations. Hello, welcome to Portugal Air Summit. You can sit over there, please. Nice to meet you. Diogo Souza, da Aircraft Propulsion V&V Lead, da Airbus, que está online e que penso que me estará a ouvir. Olá, bom dia.
Olá, muito boa tarde.
Olá, Diogo, bem-vindo. Passo a apresentar o próximo participante deste painel, que é David Aguiar Rodrigues, da Aerodrone Marketing Lead, da Airbus, que também está online. Olá,
prazer.
David. Olá,
Obrigado.
bom dia.
Olá, bom dia.
E está tudo praticamente pronto. Falta apresentar o José Folhadela Furtado, gestor de desenvolvimento de negócio do CEIA. Olá, muito bom dia. Meus senhores, bom trabalho e que seja proveitoso. Bom painel.
So, good afternoon to everyone. I would like to start thanking to the Portugal Air Summit organization to invite me in particular, APANT, the Portuguese UAS Association. So today we are now talking about a very interesting topic about unmanned aircraft systems, technology and innovation. As you know, US is creating a new industry with a large economic impact. Over the past years, the growth is being significant and exponential, with impact in the aviation industry. As well, okay, in the civil sector and in the military sector, actually they played a role from the very beginning of this technology, the military. And you can see that it's a ubiquitous systems in the battlefield, as you can see in Ukraine crisis at the moment. So we have 4 speakers for this panel. I'm starting at my left side with Mr. Achim Friedl. Presently is the president of a Joint European Drone Association that was created last year as a focal point into the EASA for drone operators. He's also the chairman of UAV DACH, is the largest drone association of German-speaking countries. Before, he was director of the German police, Bundespolizei. Will join us remotely Mr. David Aguiar Rodrigues from Airbus. Is going to talk a very interesting project about Aerodrone, and is the Aerodrone marketing responsible or head of this project. The Aerodrone is the first UAS that is meant to fly in non-segregated airspace, and it offers very significant strategic characteristics. Very interesting. And after that comes Diogo Souza, is Portuguese. Is a passionate of non-carbonic aviation, and so is expert in zero emissions in aviation. He's from UB University in Portugal. He has a master's degree in aerospace there. Then he was a researcher in UB and in Cranfield. Then he had like an internship in my company, actually in LATEC, for 6 months. And then he went to work in Airbus, and he worked in a very interesting project called Zephyr, and is the first stratospheric unmanned air vehicle. So it can fly at over 70,000 feet for months. And now presently is working in zero emissions department in aviation. And afterwards will join us from CEIA. We have Dr. José Furtado. is responsible for, actually started in North Carolina with his studies in management, in business management, and he worked in several US companies, and now he's responsible for the business development of advanced air mobility, and he showed the roadmap of SEA, that's our center of excellence in many engineering fields in Portugal. So I will start with Achim. The floor is yours, Achim. Thank you very much.
Hello, do I say to everybody. And I'm honored that I can speak at the Portugal Air Summit today. And I thank the Portugal Air Summit and the chairman of this session for inviting me and the opportunity to speak about a new drone association on the European level, which is in the air. At the beginning of 21, a friend of mine and I had the feeling that it is necessary to have an umbrella association for all the national drone associations across Europe. And then we decided to found the new organization, and that is JEDA, Joint European Drone Associations. And now we have 20 members from 19 states across Europe. You see that in the dark green. And I'm very proud that we have from the first, second, the National Drone Association from Portugal, Arpand with us. JEDA has a power of around about 3,000 members, and our seat and the head office is at Brussels. We are registered in the European Transport Register, and we are well recognized by the authorities. That means by the European Commission, by EASA, Eurocontrol,
Hello, guys.
and other European authorities, as well as at ICAO and JARUS. We are the umbrella organization for all national associations for unmanned aviation in Europe in the civil range. We are founded in November 21, and we received our legal capacity in February this year. We are the unified voice for the drone economy in Europe, and we are providing a big network for our members. And the main point is that we are the point of contact to the European Commission, the EASA, and other authorities and professional organizations in the branch of unmanned aviation. JEDA promotes research, development, design, production, maintenance, and operation of all kinds of unmanned aircraft systems. JEDA unites the European drone community and represents a common understanding for the fair integration of drones into air traffic and into the airspace. And JEDA represents all drone applications in Europe, and we are considering also global aspects in our work. And we are the focal point with a lot of expertise in the business of unmanned aviation. JEDA has at the moment 3 competence groups. 2 are already working. The first one is doing a review on the European regulation implementation in all member states, and so we get a good comparison what is going on in the member states. The second one is on training, and we are working very close together with EASA to develop the further program for the training and the training organizations. The third group on technical issues will start in around about 1 month, and then we are working in this field also. Yes, let me say something to the seamless integration of drones into the airspace. We want serviceable UAS operations. We want to do a lot for the society, for the benefit of society. We are promoting the U-space, and we are interested in advanced air mobility. And I have some examples from our members. They are very professional in some fields of the use of unmanned aircraft, and they are very successful in doing it. And this is the example from search and rescue and disaster relief, and you see drones are necessary in all fields, firefighting, flood, mountain, and so on. And the next one is about inspection. Our members are doing inspections daily with thousands of flight hours, and they are very successful. Inspection of power lines, wind energy, solar energy, and in the next slide you see what is possible with drones. And if you see these images from the inspection of a wind energy plant, the images are unique and the images are detailed, and you make it very efficient by drones. That's the same in inspection of power lines. It's also possible to have these images with very close details. And one point I want to mention is environmental friendly operations of drones. And therefore we are working in several fields, propulsion, energy sources, noise, routing and flight paths. And on this table I have put together what has to be done in the next future for the advanced air mobility. And one critical and important point is noise reduction. And noise reduction can be done by further advance of the aircraft, but it also can be done with good planning of routings of unmanned aircraft and so on. And the second one is we want to fly carbon free. And we are very well ahead of the manned aviation, because most of the drones are operating and flying today with electrical propulsion and electrical energy sources, and that's a point where technology must be better in the future. And the third point is efficiency. That's also a field where we are working. And let me mention the last point, what JEDA is doing. We are supporting our members in conferences. If a member is organizing and hosting a conference or is part of a big conference, we are supporting them. And today I do it at the Portugal Air Summit, as you see, and I thank again APAN for the invitation. And the next big event will be the European Drone Forum 22, which will take place at Cologne, and it is possible to attend on-site and also to watch this forum online. This conference is organized and hosted by UAV DACH, my German-speaking organization, and we are working close together with EASA and the German Ministry of Transport and offshore with JEDA to prepare it and to do it on the 7th and 8th of November. It is still possible to register, so do it, visit the website and register for the European Drone Forum. Thank you for your attention.
Okay. Thank you very much, Achim. So we pass to the next speaker, please. Mr. David from Airbus.
Hear me on the room perfectly?
Yes?
Yes, okay, great. So first of all, I would like to thank you for the opportunity to have this conference with you and apologize for not being able to be physically present in that room. Actually, I was listening to the aircraft flying nearby, so I was maybe missing that part. So for next occasion, I would really be pleased to be together with you. So without further ado, today I have the pleasure to present you a little bit more about what Eurodrone is. And after my presentation, we will also have the opportunity to have Diego's presentation talking about Zephyr. So in order to introduce you a bit more about what is the next generation of male ARPAs, which is Eurodrone, I would like to also give you an overview about the different platforms that we have in Airbus. So we are sharing now one slide where we can see some products that are, let's say, on the tangible side. So we have products that are already operating, coming from both categories, from the smallest to the biggest, which talking about the survey copter Aliaca, for example, that is operating with the French Navy, as well as on bigger platforms on the main category, and as our colleague mentioned, in this case, operating with the German Luftwaffe on the male category. Then, if we move to other kind of categories, we're talking about products that are more developed on the technology side. So we have characteristics that we need to test before launching a product, such as, for example, the man-and-man teaming technology that is becoming more and more critical for developing future combat air systems, for example, or a cargo drone that is under development now also with the EDA. Then on the, let's say, programs under development and being launched, we will give you more details on the Eurodrone today, but I can also talk to you about the SIRTAP, which is a tactical aircraft that will get into the 750 kilograms category, and also on the VTOL segment with the VCR 700 that is being developed together with the French customer. And then, of course, Zephyr, that Diego will give more features, that is even flying on a higher altitude, so talking about the stratosphere. Then if we have one foot closer to the future, we also talk about urban air mobility, where we have future air taxis. In this case, we have a picture of City Airbus, but we are already talking about the next generation City Airbus. And then, of course, the challenges of the traffic management of unmanned systems. So this is only to give you an overview of what we have in our portfolio for unmanned systems in Airbus. And now I would like to give you a bit more details about what Eurodrone is. So Eurodrone is a representation of the industry and political ties between, with the aim to develop not only skills on the segment of unmanned technologies, but also have a mindset of improving in this segment. So we are talking about developing the system that is going to be the reference in the main segment, and as it was introduced before by Engineer Clevio, also being the first one to be designed since the beginning to be integrated into civil airspace. And what it means also the challenge to do that in such a big platform. So, but before I get into the details on technology, I also wanted to give you a little bit overview about how is the setup. So we have finally arrived to a setup where we can talk about one-to-one. So on the industry side, we have one representative, which is Airbus Defence and Space Germany. And on the customer side, we have one representative, which is OCCAR, as an authority to represent, in this case, 4 nations, which are Germany, France, Italy, and Spain. And then, since last July, we also have the European Commission participating in this program, which means that these not only members that are launched it with the 4 nations that I mentioned, but also the 27 members of the European Union are involved in this program. Then on the industry side, we have collaboration not only with Airbus, but also Dassault in France and Leonardo in Italy, as well as Airbus Defence and Space in Spain. Then if we move more about the distribution of workload, we have talked about the platform. So if we see the physical air vehicle, we have the fuselage and the empennage being designed and developed in Spain, the wings designed and developed in Italy, and then the landing gear and the ground control station in Germany. Then if we talk about more airborne solutions as well as systems that can be connecting both air and ground, we have it distributed with France, Italy, and so on. So just to give you the message that this is how the setup is for the launch contract that has been signed this last February of 2022, and then also opening up the opportunity to have more industrial partners collaborating in the program. So just for you to be aware, we have the opportunity to collaborate in tenders that are being launched towards the goal of having a preliminary design review by Q1 next year, as well as freezing the design in the CDR by end of next year, 2023. And this opens up not only for the 4 nations that we said before, but also the opportunity for other industry members that would like to develop this system in Europe. Then if we talk about the platform itself, we're talking about a size that brings an MTOU of around 11 tons, and then an operational altitude of 45,000 feet. But maybe the main characteristics that we have to highlight from this system is its payload. Right now, there is no payload bigger than these 2.3 tons, and that gives an advantage not only on the sensors capabilities that it has, but also on the future, which is because it allows it to grow in a manner that if you want to extend its capabilities, you can upgrade the platform, increasing the payload used for sensors, for example. But also if you want to extend your mission in terms of timing, you can stay longer on target because of the fuel capacity. So if we talk about future, it's able to grow already with the frame that we are selling, and it's able to perform multiple missions. So we have advanced ISR, maritime capabilities, but also growing in the matter that I was telling you with the advantages of the 2.3 tons. And it will be certified to be operated and flying in the civil airspace, which will be a main differentiator, as you know, with the challenges of agreeing with different authorities to fly in non-segregated airspace. That is the challenge that we took on, and that's what we are aiming for. Then if we see some characteristics, well, you see first the connection to operate beyond line of sight, so it will have a SATCOM. It has a front radar as well to give visibility for both day and night. And then in terms of size, we have, just to make it simple, very similar size as an A320. So it has a width of around 30 meters, length of 16 meters, and so that you can imagine that civil aircraft that you have operated to fly to get to Portugal or to fly these days to go to any other business meeting, it's a similar size, so it's not a small platform. And then just to summarize some of its features, 2.3 tons, it's able to fly over 45,000 feet, but also in terms of sensors and capabilities of the missions, it's able to perform with better resolution and with better capabilities on the mission. In the end, taking on the challenge to certify it for flying in civil airspace, it will become a reference for the main segment. And then just to give you an overview of what are the next steps, for next year beginning, we will have the preliminary design review finished. By the end of the year, we'll have the critical design review finished as well. That's why we're calling for tenders to be applying on the different work packages that we have opened. And then first flight by 2026, and the first delivery of the systems to Germany by the end of the decade in 2029. So this is more or less an overview, but of course, if there are more questions, I will be happy to answer them. And now I would like to hand the presentation to my colleague, Diego. Thank you very much.
Hello, good afternoon. Has the presentation been changed already? There we go. Okay, good afternoon. Could you tell me which aircraft performed the longest ever unrefueled flight? So we may think about the A350 Singapore to JFK, which is done in about 19 hours, or the longer endurance ARPAs, as for instance the Aerodrone that my colleague just presented, which has endurance of up to 40 flight hours. So today I present you Zephyr, the world-leading solar, electric, and manned aircraft, which flies not for hours, not for days, not for weeks, but rather for months in a single flight. So Zephyr is a high-altitude pseudo-satellite, HAPS, and it fills a unique capability gap because it combines both the persistence and the wide coverage of satellites, but also the flexibility, the retasking, the accuracy and low latency of conventional manned and unmanned aviation. Zephyr has collected multiple achievements since its beginning in 2001. In the last couple of years, being Airbus, we actually kept breaking our own endurance records. We did in the last couple of years a flight of 17 days, then 25 days, and this year 64 days. So actually last year, in 2021, we applied for 3 world records that were received: absolute unrefueled endurance, class unrefueled endurance, and class through altitude. So far, we have more than 4,000 flight hours in the stratosphere. And again, for this year, we've flown with Z-82, one of our aircrafts, and in these 64 days, we covered about 140 nautical miles. It's approximately 7 times around the world. So Zephyr flies in the stratosphere. It flies at about 65,000 feet, and today the stratosphere is an untapped and underdeveloped resource, which Zephyr is pioneering. On the left-hand side, you can see exclusive footage of the Zephyr flying in the stratosphere. It might be worth saying that it's a wingtip camera. So it's only for engineering monitoring of the aircraft during flight. So it's not representative of the high resolution that our cameras have. Still very, very interesting to see an aircraft flying the stratosphere for the first time, I believe. On the right-hand side, our altitude profile. It's really a graph that I could not miss to show here, because it's proving our day-to-night persistency. This is the big achievement that the team has done in the past years. So in blue, you can see the Zephyr 7 standard, so our previous aircraft standard, and in red, the Zephyr 8, the current aircraft standard. And what you can see here is that the altitude on the y-axis over the several days of flight, the altitude in the Zephyr 7 in the blue was not being able to be kept in the stratosphere at 60,000 feet during the night. So it would be flying at 65 to 70,000 feet during the day, and it would descend to about 60,000 feet during the night, and so well below 60,000 feet during the night. So it was not possible to keep it on the stratosphere. Whereas for the latest standard, so our current aircraft, we finally achieved staying persistently in the stratosphere. This is a tremendous achievement, and there is no other company today remotely close to achieving this. So if ever you get approached by other apps, products, please ask them this plot, ask them the altitude profile. And if they don't have this capability of staying during the entire night in the stratosphere, they are not in the game. So Zephyr is indeed an innovative product. It's sustainable, 100% electric, it brings persistency, and its value is given by See, Sense, and Connect. So, but how did we actually accomplish this capability? The whole aircraft is powered and mass optimized to single digits of grams and watts. For instance, the propulsion system where I worked on, we were optimizing it by the watt. So not kilowatts or megawatts in conventional aviation, but single digits of watts and grams. So this brings the capability from a platform perspective. So as you can see in our specs in the slide, we have about 25-meter wingspan, but the weight is below an average adult. So even a A320 chair, rather than the Aerodrone, which is the entire A320. Also, its endurance, it's worth noticing, It's about 300 days of operation target, and it's really only limited by design due to moving parts, so it could in theory achieve 2 years of operation. In a nutshell, how does Zephyr work? So Zephyr is a solar-powered aircraft. So the photons from the sun are converted into electrical energy by solar arrays and transmitted in the aircraft to the systems and propulsion system to propulse the aircraft. All the energy that in excess that is not used during the day is stored in very high capacity batteries, and these batteries then allow the aircraft to fly during the entire night for cruise in the stratosphere. I finished this slide by saying that Zephyr is the world's only UAS flight proven for day to night persistence, as you saw in the previous slide. So now in terms of our capability, in terms of payload possibilities, Zephyr is a dual-use payload agnostic platform. So it can serve both civilian and military applications. It revolutionizes defense, humanitarian security, and environmental sectors. We have Earth observation and sensing and connectivity, and I'm going to give you some examples of that. So here you can see some pictures of Zephyr actual pictures done on using our OPAS payload, which is an Airbus payload as well. And you can see the very high resolution that can be achieved, 18 centimeters GSD Earth imagery. So this is actually comparable and to very high tech on satellite capability. And then in terms of the connectivity market, our altitude is key. So we are low enough to Earth that we still have a low latency
Diogo.
of less than, hello?
Diogo, please go speed ahead a little bit. So
It's 2 more slides.
Yes.
Okay, I'll do, thank you. Low latency of less than 10 milliseconds and high enough altitude that we can cover 250 terrestrial towers. So this connectivity market has really been confirmed in 2021, and this enabled Airbus to create a new connectivity business and a dedicated Airbus subsidiary that will be the next step of Zephyr. So I finished with an image of our production facility in the UK and the message that it is an exciting time to do engineering and aviation. Thank you.
thank you, Diogo. Most interesting. So José Furtado, please.
Hi, good afternoon, everybody. My name is José Furtado. I am from SEIA. I'm sure most of you are aware of what SEIA is and what we do. Obviously, if I had a little more time, I would explain you and give you the whole context of everything. SEIA is a center of engineering and product development that conceives, develops, and productizes new technologies, products, and services in the areas of automotive and mobility, aeronautics, ocean, and space. Obviously, this multidisciplinary activity has given us an edge to really focus on integrating horizontal mobility with vertical mobility, and now really focusing on cities. Over the past few years, we have launched a new business unit for advanced air mobility. Right now, our biggest focus is bringing drones into our cities. How are we going to do that? So we created a roadmap that really focused on doing exactly that. And in the beginning, we are developing safety mechanisms and device to make that happen. You know, retrofitting market available drones with flight termination system, as well as safety parachutes and detect and avoid technology. We're able to apply for the permission of local and international authorities to fly within medium and high risk, and high risk categories of areas to bring those drones closer to our cities. Again, like in the beginning, right now we have just started by creating these pilot missions and accumulating and validating this technology through flights under the open category. And in a little bit, I'll present you a little video about it. But really, the idea is to accumulate these hours and continuing flying and validating this technology so that we are bringing this closer to people. Public acceptance is still a big part of, it's still a big challenge because people are still skeptical about what is this going to be all about. And again, within the projects that we do, we're also open to collaborating with other people and other companies so that we can move forward with this technology. And right now, I'll play a little video of some demonstration we've done recently. Thank you. So again, medical emergency deliveries and as well last mile logistics are with what we are working on right now, and this is what we do. Thank you, Mr. Late.
So it's over. So thank you very much, José Furtado. I would like to ask some questions, and actually the first one will be to Achim here at my side. In what regards the operational authorization by your civil aviation authority in Germany, how is currently the situation? Is being easy to get it? Do you feel any bottlenecks in the regulation presently issued by EASA that should be advanced or improved?
Yes, at first, let me say EASA has worked very quick to put the regulations on the market, and that means that there is improvement necessary. In Germany, we have one problem with the flights beyond visual line of sight because we are operating in airspaces where manned aircraft also are flying. And at the moment we have no detect and avoid equipment which can do it automatically, so that the drone urges no risk of collision with other aircrafts. And there's a lot of improvement necessary even in the regulation, and the second point is in U-space. We have this framework, and it's a task of the member states to see that the regulation will come into practical procedures, and there's a lot of work to do.
Okay, thank you very much, Achim. And I'd like now to ask a question to Diogo, and about the Zephyr. It was a very striking presentation. I know about it. It's kind of a dreams come true. And I would like to ask, when is Airbus in the position to start offering this type of services to agencies, civilian agencies, and to military allies about these ISTAR capabilities?
Thank you for the question. So our official entry into service is 2024. So in 2 years, would be able to bring this capability to the wide market. We have today already some customers that we are providing capability to in a restricted manner. And from 2024, we believe would be in a position to widen this offer.
Thank you very much. Thank you, gentlemen, for your excellent presentations, and looking forward to next year. Thank you very much.